Hello guys, this is just a quick video to show you how to set up all your inputs and outputs on your ECUMaster ECU. The base maps that you can sometimes load up are specific for a particular setup. That doesn't necessarily mean they are specific for your setup. So what we're going to do now is I'm going to try and go through as quickly as I can. I don't want this video to go for like 45 minutes. So we're going to go simple step by step exactly how to do it. I have actually already done this one, so what I'm going to do is I'm going to go through the process that I go through and show you how to set everything up to how you want it. Okay, so first of all, obviously we're in the software. Alright, this is the map that we're using on this particular ECU. It's for a 2JZ GT VVTi. Okay, so once you're in here, you've obviously got loads of tabs at the top that you can go between. I always start by looking at the triggers. So effectively, what we've got here is we've got our crank trigger or primary trigger over here, and we've got our secondary trigger over here. So we just quickly glance over this, make sure it's all correct. So we've got a variable reluctance sensor, that's correct. Obviously you don't need to pull up a pull down resistor with a VR sensor. Trigger type, so we know it's a 36-2, so it's a toothed wheel with 2 missing teeth. If you wire the crank and cam sensor as per Toyota's wiring, which one's negative and positive, you need to put it on falling edge, so that's all correct. Number of cylinders 6, 2JZ, we know that's correct. Number of teeth including missing, 36, that's all correct. So these are related to setting your base timing. So I'm not going to delve into these right now. We will do a separate video on base timing. And obviously you've got the other ones down here. So for our purposes right now, that is pretty much correct. We know exactly what's there. We are locking the ignition angle at 10 degrees because the first thing we're going to do before we try and start it is we're going to check base timing. That is the number one. You have to check base timing before you start it. I can't stress that enough. Don't assume because it's a 2JZ map that it's correct. Assumptions get you nowhere. So secondary trigger, this is the cam sensor now. So we've got VR sensor, that's correct. Again, no pull down resistor. Now they do have trigger types for multiple different engines. So I'll just quickly show you here. There's a lot. So you've got your 1UZ VVTi, you've got your 3UZ VVTi, which is actually the same trigger, but I don't know why they separated that out. Anyway, and 2JZ VVTi 3 teeth. So all the VVTi JZs and UZs have a 3-tooth pattern, which is a small, medium, large. So basically you want to choose the correct one for your setup. In this case, we're using a 2JZ VVT. Again, so we want to make sure trigger edge is falling because we've wired it as per Toyota's wiring, and that's that. So in this terms of this, I am happy. And next thing I'm going to go and have a look at is to check and make sure that this is all correct. So this particular case, we're using Audi coils or VW coils. So these are going to be coils. We're not using a distributor or dual distributor. So obviously if it's a 2JZ non-VVTi with a distributor, you can use this. If it's a 1UZ non-VVTi with a distributor, you can use that setup as well. Okay. And coil types, so in this case, because they're coil over plug setups, they are coils with built-in amplifiers. So coils without amplifier basically means the standard 2JZ VVTi coils, where there's 3 and they do wasted spark, and they're dumb coils. They've only got 2 wires to them and they need an igniter to make them work. So just make sure you always choose the correct one, otherwise you can do some damage. So in this case we want to go coils with built-in amplifier. Now this output offset, basically what that means is if, for instance, say that the coils are wired wrong and you want an ignition vent to start later. So in this case, we know that the firing order for a 2JZ is 153624. But let's say we wired up in an incorrect manner or whatever, and we wanted basically ignition event 1 to start at number 2. We'd obviously just change the offset 1. So that would then move the first event to this one over here. So it'd move it from 1 to 5. If wired correctly, you shouldn't need to do that, but it's quite useful sometimes if you have wired incorrectly. Instead of having to go and rewire everything, you can just change the output offset. You can also just change the ignition output on this one over here. So if it is wired incorrectly, you just change the ignition output here. That'll rectify your issue. So again, nice little feature there. Okay, so we're happy with all of this. Now we're happy with all of that. We're happy that all the information on the engine is correct. So now what we're going to do is we're going to go look at our actual outputs. Okay, so we obviously supply these as part of our pack that you get when you buy an ECUMaster product from us, and we all wired up. So this will tell you and your tuner exactly where everything is in case they need to do anything or in case any sort of diagnostics need to be carried out. So what we're going to do now is we're going to start by looking at all our auxiliary outputs. So there's a nice little feature here. You can go tools, you can go show assigned outputs, and it's a complete pinout of all the outputs, and you can see exactly what is where. Okay, so we can always use this to verify, and we can go from there. So just to sort of assume that you're fresh and you've got a new map, or you've done a base map, you put it on, now you want to go through all your bits and bobs. So let's go over here. So we're looking at auxiliary 1. Okay, so the ECUMaster Black auxiliary 1 and auxiliary 2 can actually be injector 7 and injector 8. This is how they work on sort of a 3UZ VVTI or a 1UZ VVTI. So just bear in mind they will work, but you do lose 2 auxiliary outputs in order to do so. So auxiliary 1 in our case is going to be FC or fuel control, so that's going to be our fuel pump output. So at the top here you can see we've got outputs fuel pump. Alright, we can set the output, in this case to auxiliary 1, and what you can do is, it says after start activity, but basically what that means is when it gets ignition. So in this case it goes on for like 0.2 seconds. One nice feature about this is if you are using something with like a idle control valve, and that idle control valve needs to reset into its default position, and let's say that takes 3 seconds, just change that to 3 seconds, then you know when you turn the key on, by the time the fuel pump stops priming, you know that your idle control valve is in the correct position. It's not something you have to do, but it's just a nice feature if you do want to do it. Okay. Alright, so change it back to auxiliary 1. So you saw what happened there. As soon as I actually accidentally put auxiliary 2, it's telling me there that there's a problem because auxiliary 2 is being used by something else. And another way to figure that out as well is if you go to a show assigned outputs, you'll see there 2 auxiliary 2s are assigned. One is output for fuel pump, one is engine protection light. So let's just change that back to that one. So it will warn you if you try and set it to something that's already there, and then you can either change the other one if it's in the wrong place, or change this one if it's in the wrong place. Okay, so that's auxiliary 1. Now we've got auxiliary 2. So that's W, or check engine light. Sorry, that's the Toyota term for check engine light. So check engine light, what you need to do is you need to go into engine protection. Then you can go check engine light. That will then open up this tab over here that I've got here. So I've set the output as auxiliary 2, which is correct. Okay, and these are the options that I've ticked for it to cause a check engine light. So we've got a wideband oxygen sensor, we've got an IAT sensor, CLT, map, we've got a Bosch wideband NOx sensor, so we can cause a check engine light for that, and drive-by-wire, and we've got a fuel pressure sensor, so we can again cause a check engine light to come on if that particular event happens. So that would depend on exactly what you've got. If you've got EGT sensors, you can set those up. If you've got a flex fuel sensor, you can set that up as well. So this is something just to effectively in the car, you're not going to have your laptop plugged in all the time. You wouldn't know if the wideband oxygen sensor failed. So again, this is quite useful just to have. So you can just output a check engine light. So like a normal car, check engine light comes on, you know something's wrong. Plug in the laptop, see exactly what's causing your issue. Okay, so that's the check engine light done. So next up, auxiliary 3, that's going to be our oil control valve. So oil control valve is the VVTI solenoid, is the other name for it. So in this case, what you would do is you'd go to VVT. Alright. Now you've got VTEC Control, that's the on-off system. Then you've got the ability to run 2 VVT cams, which is again why it works with the 3UZ and the 1UZ VVTI, because you can hook both of them up. So if you double click on parameters, that's going to bring up this box over here. Now, if you used an ECUMaster base map that is designed for a 2JZ or a 3UZ or a 1UZ VVTI, this information is actually already filled in. So don't worry about this too much. Just make sure that you've actually set the auxiliary solenoid output correctly, just so that that's all done. Okay, so that's auxiliary 3. Then we're going to go to auxiliary 4. Now, auxiliary 4 is kind of standardized as a tacho output by ECUMaster. It is in the pinout and so on, so we just leave that exactly as it is. So you'll see here on tacho output, we've got auxiliary 4. And the RPM multiplier is how you adjust the signal for the tacho. So I've got a separate video on that, so if you want to go through and have a look at that, that'll tell you how and what happens when you change those values and how to correct it for your particular vehicle. Okay, so that's auxiliary 4. Now we're going to go to auxiliary 5, and that's our Mac boost solenoid. So in this case, you're going to go to boost, you're going to go to parameters, and you'll see that's going to open up this little tab over here. So just to let you know, I've obviously gone this up, but I've opened up all these tabs separately, so you'll just click and open them up as you go through. So we can enable boost control. You can choose open loop or closed loop. I would assume that your tuner is going to work in open loop first to get the settings correct, and then it's going to switch over to closed loop to let the ECU take control of it. Your solenoid output, again, in our case, is auxiliary 5, so that's fine. And then all of these settings is just going to be specific to whatever boost solenoid you particularly have. Okay, so that I don't have all the settings for your particular setup, but yeah, this is where you would put them in. All right. And next up, we have got auxiliary 6, which is going to be oil light. So in our case, because it's a standard vehicle, what we've done is we've got a spare auxiliary output, so we're now using that to output an oil light, because the oil pressure sensor that we fitted to the engine is obviously going to feed that information to the ECU, but you've got nothing on the dash. So this particular customer is not having a digital dash or an ECUMaster dash, whatever that. So what we like to do is put an oil light on just so that he can have that for his own purposes. So in order to do that, as you can see from, I'll just minimize this. So we've got outputs, we've got things like AC clutch, coolant frequency, that's like for a Honda S2000. You've got coolant fan, fuel pump, Honda, coolant temp for the dash. Your main relay if you want to control it via the ECU, speedometer and tacho output. What we don't have here is the ability to have an oil pressure output. Okay, so what you're going to do then is you're going to go into parametric output, and you've got a few here that you can have. Let me just see if I can move that out. So you've got 1, 2, 3, 4 and 5, and then you've got a virtual one as well. So in our case we just want to use a parametric output, so if you double click on that you'll get this tab over here. Now you can add your own username for whatever it is, set the output, which in our case is auxiliary 6, and then what you're going to do is you're going to start to look at the variables. So in this case there are a lot of variables that you can have. Okay, so in our case we want to have oil pressure. All right, and effectively what we're going to do is we're going to look for when the oil pressure is lower than whichever value that is. So this is in millibars, so just do your calculation to PSI if you want to do that, or if you're happy with millibar, work with that. Now hysteresis, that basically means is how much it needs to change by in order for the light to go off. What I mean by that, I'm going to try and explain as best I can. Let's say for instance in this case your oil pressure dropped to let's say 98. Okay, it would need to go up by 10 before it turned off again. It's just so that you don't have a situation where let's say for some weird reason you set that variable to be almost like dead spot on where it's idling. So effectively what you want to do is the hysteresis will give you that 10 millibars either side, so that basically if it's hovering around 100, it's not going to keep going on, off, on, off, on, off, on, off, on, off. So basically what it'll do is it'll wait until it gets up by another 10 millibar before it turns off. So this is where I would probably just get the engine warm, let it idle, monitor the pressure that you're seeing at idle, and then pick a value sort of maybe 10, 15 millibar underneath that. So when you go from there, so don't get this confused with oil safety features that are in the ECU. This is completely different. This is just an oil pressure light. So this is just something for the dashboard that you can go from there. Okay. Down here you do actually have, under engine protection, you do have oil pressure cut. Okay, so that's a completely different thing altogether. So this is when you can actually enable oil pressure cut. Okay, so you can set up your things like your delay or your restart time and so on and so forth, but with that you actually have a whole table. So this table is based on RPM. So as you can understand, or hopefully you know, obviously the higher the RPM is, the more oil pressure you've got. The lower the RPM, the lower your oil pressure is. So the thing is, let's say for instance, just random numbers, let's just say 100 millibar is where it idles at. Okay, so the oil pressure at idle is 100 millibar. Let's say at 6,500 RPM you've got 80 psi of oil pressure. Okay, now if you set your oil light to come on when the pressure is lower than 100 millibar, because that's effectively where you idle at, so you don't want it to come on every time it's idling, what this will do is it'll actually cut the ECU and cut the engine depending on where you set this table. So effectively, if you know that at 6,000 RPM you've got 80 psi of oil pressure, you can set this to maybe say 70 psi. So what happens if it hits 6,500 RPM and you drop below 70 psi of oil pressure? Clearly there's a problem, and it will cut everything out to try and save the engine. Okay, so that's completely different from the oil light. The oil light is purely there just so for the dash to work. So two different things, don't get them confused. Okay, so that's all the auxiliaries, 1 to 6 that we've set up there. The H-bridge 1A and B, that's our drive-by-wire motor that's using that. And H-bridge number 2 winding A and B, we're not currently using. We've just taken them to an auxiliary plug so the customer can use them if they so desire. Okay, so that's all our auxiliary output setup. So if we go into tools and we go show assigned outputs, we can see there auxiliary 1 fuel pump, auxiliary 2 check engine light, auxiliary 3 VVTI solenoid, auxiliary 4 tacho output, auxiliary 5, boost solenoid, and auxiliary 6 are parametric output. Okay, so that's absolutely fine. Then we know we can see all injectors set up there, 1 to 6. We can see drive-by-wire is set up 1 to A and B, and we can see ignition 1 to 6 is set up there as well. So that's absolutely fine. Okay, so now that that's all done, what we're going to do now is we're going to start looking at the inputs that we have. Okay, so there are some standard ones, coolant temp, TPS, IAT. These are all sort of set in stone. This is how you pin it out. So there's not really much you can do there. So what we'll do is we'll open up another tab here and we'll start going through what we've got. So going to the top here, I'm just going to close all these tabs down. So going into sensor setup, we've obviously got TPS. Okay. So basically what we've got here is how to set up our TPS. So what we're going to do now is just a quick note. When you're doing drive-by-wire with the ECUMaster, the way you wire it is your TPS is actually your pedal position sensor, and your actual TPS on the throttle body goes to analog 1. Okay, and that's in your drive-by-wire setup, which we can have a look here. So you'll see here that we've got position sensor input, analog input 1. So that's effectively where our analog input 1 is going. That's going to the actual TPS on the throttle body. TPS input is actually your pedal. Okay, so let's go through that. So in other words, this is going to be your TPS. It is set in stone. These particular values over here you're going to find out by obviously opening and closing the pedal, and that'll give you which one is that. So if you want to see that information nice and easily, you come down here, you open tune display, you go along there. Now obviously I'm not plugged into an ECU here for now, but you'll see TPS over there. That is a percentage value. That'll be 0 to 100%. So what you would do is you would change your log channel to TPS voltage. Okay. Now what that would do is give you a voltage. So you let go of the pedal and it would say 0.41 volts. You put that value in there. For opening fully, it'll say, in our case, 3.69, and so we enter that value in there. Okay, so that's how you set up the TPS, or in this case, pedal position sensor, and that's nice and easy. Okay, so that takes care of our analog 1 input, because effectively that is our actual TPS on the engine itself. Alright, so now we're going to go over to analog 2, which we can see here, and that is oil pressure. Okay, so we're going to go back up to sensor setup. Now here we've got pressure, and underneath there we've got parameters. Okay, now we can choose what sensors we've got. Okay, so now we can go down and we've got oil pressure sensor input, and you'll see here this is already on analog input 2. So confirm that analog input 2 is oil pressure, so that's absolutely fine. Okay, you can put an oil pressure switch into the ECU if you want to, instead of putting an oil pressure sensor. I don't really see much point in doing that, to be honest with you. Oil pressure lights are pretty dumb. By the time, if you're at 6,000 RPM and your oil light comes on, goodbye engine. There's not much you're going to do about it. So that's that setup there that you can do. Obviously, these ones down here, this is how you set up your oil pressure, or what they call the oil pressure calibration. So for instance, these values here seem pretty standard to people who set up before. So in other words, if you had a 150 psi sensor, which is I think about 10 bar, so 0.5 volts would be 0, 4.5 would be 10 bar. Okay, nice and simple, easy to do. So just get your settings from your particular sensor and input those over there. Okay, so let's go to analog 3. So analog 3 in our case is going to be fuel pressure, and you can see here we've got a fuel pressure sensor input, and that is analog 3. So that's all set up there. And again, now we can go to fuel pressure calibration. Now we know we've got a 150 psi sensor, so it's 10 bar. Simple as that. There you go. That's all done. All right. So let's go to auxiliary 4. Analog 4. Okay, so analog 4 is going to be fuel temp. Okay. So now we're going to go from pressure, we're actually going to go to temperature. So as I said, IAT and coolant temp are sort of standardized. They have dedicated wires in, that's why you have these two over here. But when you go to temperature, we're going to go to parameters. So again, we have a choice of temperature sensors that we've got. So in our case, what we're going to do now is go back in there. Okay, and we're going to use fuel temp. Now, the customer's not actually using fuel temp. This is just one of our modular harnesses, so this all gets wired in case he wants to at a later date. So what we'll do is we'll set it up here already. It's not going to take any information, but obviously it's just so already set up, so if he just wants to buy another modular harness with a fuel temp sensor in, it just plugs it in and away he goes. Okay, so fuel temperature sensor input. Now in this case you've got flex fuel sensor. In our case we've got analog input 4 that we're going to be using for that one over there. So again, nice and simple. Again, you've got your fuel temperature calibration over here in the side. Okay, so once you've got that sensor information, you can input that over there. All right, and we're going to go to analog 5. So let's find analog 5 quickly. Analog 5. Okay, so analog 5 is going to auxiliary, so it's not dedicated to anything. It's going to an auxiliary plug on the inside for customers' future use. Analog 6 is going to the auxiliary as well. So that pretty much covers that. Flex fuel is going to auxiliaries. All the 3 switches are going to auxiliary. Same with the CAN and the RS232 communication. So that's going to be fine. So again, what we can do now is we can go into tools and we can go show assigned inputs. So what we'll do is we'll just check and make sure this is correct. So again, we know switch 1, 2, 3 is obviously going to auxiliary plug, so it's not assigned to anything. We've got analog input 1. That's our drive-by-wire TPS sensor. Analog input 2, that's going to be oil pressure. Analog input 3 is going to be fuel pressure. And analog input 4 is going to be fuel temperature, which is part of our modular harness setup that's in the front there. Okay, and that's pretty much it in terms of what we got there. So you can see nothing else is assigned, only those 4 that are there, and that is exactly what we wanted to do. So everything else is pretty straightforward. So we've got everything set up that we wanted to. I've got the drive-by-wire here. We're going to do a separate video on drive-by-wire, how to set it up, what happens when you set it up. They do have a self-calibration tool, so it's not incredibly difficult to set up. It's effectively just clicking a button, and as long as everything's wired correctly, away you go. Okay, so we'll do a separate video on that just to give you more information. We'll actually have a throttle, and we'll show you exactly what happens with that throttle while it's going through the calibration process. But that's pretty much it for that. There obviously is, depending on your harness, depending on your options, depending on that, there's a lot on here. So, oh, actually, while I'm here, nearly forgot about that. Right, so wideband sensor. So in our case, we are using a wideband sensor. We are using an LSU 4.9. Okay, and you do have the option of an external controller. So if you have a spare analog input, and let's say you've got an external controller for a wideband that gives out a 0 to 5 volt signal, that's the option you would choose. You've also got the ECUMaster Lambda to CAN, so if you do have that particular thing set up, that's how you would do it. And then in this particular case, I think it was because HPA Academy, they actually put in the CAN data for the Haltech Lambda controller. So that's another option that you got from there. So in our case, LSU 4.9. Just make sure that you set up correctly. So it seems to be the default is gasoline, basically E85. So that is not correct in our case. We are just using gasoline, normal petrol, and heater mode. So this is basically how fast the O2 sensor is going to heat up. So you can have 3 options. Number 1, fast heat up, which is basically probably what your tuner would use because he wants to get the information as quickly as possible. Let's say you want to do cold start, etc., etc. You would need that information as fast as possible. Always active. As it says in brackets here, may shorten the sensor life, so just be aware of that. You don't really want to leave that on. I always leave it on conservative heat up, simply because once your engine is tuned, your cold start map and everything should be relatively straightforward, and let the O2 sensor heat up in its own time. It'll lengthen the life of your O2 sensor, and it's not really necessary for it to come on, you know, either always be on or have a fast start up. So those are the options you can have there. Okay, so I'm just going to quickly run through this, and we've got the wideband in there. Right, let's go to knock quickly. Okay, so sensor parameters for knock. Okay, this is what your tuner is basically going to set up for. Again, these are pre-input for this one. Now this base map, we're not 100% sure whether or not these were using Bosch wideband knock sensors. This could be the parameters for the single wire narrowband knock sensors that come on a JZ engine. So don't assume this is always correct, but just leave this as it is. Let your tuner do all of that, and there's a whole bunch of things down here that he's going to be able to choose from, so we can sample knock. And obviously this table over here is going to let him put in engine noise, so that all gets sort of filtered out when it's looking for knock. So just have one more look in here. Okay, we've got cam, we've got ground, we've got fuel temp, that's your TPS. let's do IAT and CLT. I nearly forgot about those, so just bear with me a second. I'm going to go into here. Okay, so for the IAT sensor, you can just use the wizard. There's also one for the coolant temp over there, but basically if you know exactly what you're using, so for instance if you've got a Toyota 1JZ GT sensor, just use that. If you're using a Bosch NTC sensor, just use that. Okay, so effectively you just go there and you can choose your option over there and it will automatically put it in. So as standard on the ECUMaster Black, it's got a 2.2K pull-up resistor on both the intake air temperature and coolant temp sensor, and here's where you can put your own values in. Okay, so if you have 3 points to choose from where you know what the values are, you can put it in here and it'll automatically generate it for you. If you really wanted to, you could actually open up IAT calibration, and there you go. There's your voltage, that's your actual temperature, and you can set this table up as and when you want. So if you can use the wizard, brilliant. If not, you can set it up yourself. So again, it's really simple. It's exactly the same thing. Choose your sensor from there, click on OK, and that'll all be set up incorrectly for you to go. All right. Map sensor. Now then, obviously the ECUMaster Black has a built-in map sensor. Do you have to use it? Not necessarily. You can actually wire up your own map sensor to live in the engine bay. So if you didn't want to maybe run a vacuum hose into the engine bay from the inside, not a problem. Wire up a map sensor and you can put it into there. Okay. So in this case, we're using the built-in map sensor. Okay, and that's effectively how that's going to be used. So if you're not using the built-in map sensor, you can obviously either use it as a baro sensor, so you can use the internal map as a baro, or use an external baro sensor if you wanted to. That's obviously there for you as well, but that's basically that. So in this case, we are using the built-in map sensor, so we're going to tick that option down there. Okay, and so going through there, we've got that. We've got all analog inputs out. We're not using vehicle speed sensor or gearbox from there. Okay, so that's about it. So, 26 minutes is quite a long video. I did presume it was going to be a little bit long, but that's absolutely fine. So, that's effectively how you set up your inputs and your outputs. Just as a sanity check, we're going to make sure we got no red marks in there. That means we've got nothing conflicting when it's going through there. Again, we've got nothing in red here, so we know nothing is conflicting from there. So you're happy with that. You just click on save. Let's just do that. Yeah. Right, now that is saved. Now we always set all of this stuff up if you're buying from us, and we'll have this sort of base map all set and saved on our system. So if you ever get too far in the other direction and you want to go back to square one again, you could just give us a shout and we'll send you that base map on there. What could be advisable is when you first open up your ECU and you plug in your laptop and you are doing this, just save it. Just save it in your own computer as your base map. You can always come back to it later, but this will effectively have all your inputs and outputs set up correctly. But that's pretty much it. That's how you go through everything. It's not a quick process. Obviously, I've done most of it already, and this is a half-an-hour video. So if you are coming in completely from scratch, you need to go through each and every little thing. You want to make sure that nothing is getting in the way. Using those particular tables to see all your assigned inputs and outputs, make sure there's nothing in red. You'll be scratching your head for ages. If something is in red, then you just haven't looked. And you've just gone through the basics, and you say, oh, that's all right, no problem. Just check it. If it's in red, sort it out, and then everything should be fine. So that's pretty much it. That's how you set it all up. Now this should be ready basically to go on and test the actual outputs on the engine itself. So the next video we're going to do now is actually doing that. So we've got the engine set up here with the ECU. We are going to be effectively going through each and every one. So we're going to be testing all the injectors, all the coils. We're going to test all the pressure sensors with compressed air. We're going to go through all of that. But I'll leave that up to the next video. So thanks for watching, and we'll see you in a bit.